Hi guys, welcome again to my YouTube, and for this video I want to show you some new technology, some new products that have hit the market with Banner Engineering, and gotten a lot of questions recently. I've had to do a little bit of work with the Snap Signal, so I wanted to make this video and see if anybody out there learned something new. So I want to start off with a demo of Snap Signal, what it is, and then I'm going to show you some of the signal converters as well. And then I'm going to go over the DXM software on how to do the register mapping. I am going to break down the timeline of this video, so if you just want to forward to the register mapping, you can do that and skip over the demo, whatever you need. So anyway, so let me turn it over now to my other video camera here. I've got a demo. I don't know if you can see that. What I've got here is my Snap Signal controller, also known as a DXM R90-X1. And what that's doing is taking these 4 channels, these 4 ports. They are individual Modbus RTU masters. So yes, each port is independent, has its own baud rate and parity settings, so you can have multiple devices on here that are different types of settings. You can also, because of Modbus RTU and it has a daisy chaining feature, right, the protocol, so you would use like a little T-splitter that we make to bring all of those into one channel. So once it gets into the Snap Signal controller, we notice this cable here, the blue cable is our industrial Ethernet output. So we're converting from RTU to TCP/IP. So the protocols we support are going to be Profinet, Ethernet IP, and Modbus TCP. So that's going to be a really awesome way to have this act like a gateway. And then this here is just my power connection to power supply. Okay, and so in this demo, what we have going on is a bunch of these different we call them Snap Signal converters. So these little converters are actually converting different types of signals into Modbus, or we have some that are actually for IO-Link. So you'll notice that we have this Q4X sensor over here, standard laser measurement sensor. And that is connected to a converter that's making this sensor into a Modbus sensor. So now I'm actually getting this data into the Snap Signal controller via Modbus RTU. So that just, if you have old legacy equipment, this is a really great solution to just get a bunch of your IO data onto one network and consolidate protocols. And then I've got a couple other devices that are Modbus as well. So this one here, this is brand new. I know you can't see it very well with the camera here, but it is a Pro Lite, so it's programmable, and it is Modbus. So you can actually write like a string or a value here to the LCD. Yeah, you see that inverted value, it's actually 76. That's the temperature that it's taking from this temperature and humidity sensor. There's a circle around here, and as it starts increasing in temperature, it will light up. All right, so I'm gonna go ahead and move on with our demo here to do the register mapping in our Snap Signal controller. So if you open up the software, you'll notice there's a drop down here, and the model that we're working with is the R90X. So if you have that selected, it'll show you the little picture of the item. And you want to make sure that you're in configuration mode for traditional setup. Okay, so the default IP address on these R90X1s are going to be 192.168.0.1. So I'm just going to go ahead and connect to that. Notice that when I connected, it did give me a status indication, and the light is green here at the bottom, and it says I'm connected. Okay, so let's go ahead and look at local registers. So if you haven't tuned in for one of my videos, which I haven't made one in a while, I think we were still on version 3 of this software. So anyway, there is version 4.12 now. So make sure you're updated to the latest and greatest. And here we have the local register view. Notice there's nothing in here because it's a brand new database. So this is where we configure the serial side, the RTU side of this R90X. So you'll notice on the RTU configuration, this is going to be your settings for your ports. So you can have different baud rates from 1200 to 1152, different parities available, and then comms timeouts that you can set up. Okay, so they're all independent. So under RTU read, this is going to be our read rules or our inputs, right? And everything that I want to read in. And so for today's example, I'm taking these vibration sensors and I'm just going to grab the data that's in there. So for this demo, I'm going to unplug here. And before I start doing my read rules and all of that, I need to make sure that all of my devices have the correct ID. In this case, to do that, we have to hold on here for a sec. And you've got to get this cable, right? You might already have it. It's the BWA-UCT-900. It's a special dongle that we use for RS-45. And so I'm going to bring down this software and I'm going to open up sensor configuration. And all of this is downloadable on our website, bannerengineering.com. Let's go ahead and I am already connected here. If you, for whatever reason, can't open this up, I always tell people, make sure you go to your device manager. And if I'm connected on here and I go to ports and I open that little folder, I'm going to see that I have something connected here to USB port COM13. So once I identify that COM number, I mean, you can try all of them, right, that pop up here, but I can make sure that that one's connected. And if it lets me connect, that's great. And it did, that was quick. Here it says connected, COM13, application status green. So we're good, we're connected. And there's a button here that says show advanced options. So I always like to keep that available. And if you go over here to your settings, this is where you can actually give it the device ID. So if I go here to Modbus ID and I do a get, it's going to tell me, okay, I'm on Modbus ID 10. If I want to change that, this is when I would enter the value and click set, and then do a quick get again, just to make sure it actually took it. And since we are on the ID that I wanted, I'm good with that. So I'm just going to go ahead and close that. And I'm going to disconnect my sensor, put it back on my Snap signal controller. I'm on port 4. Go ahead and open up our software. Now we're ready to do that read rule. So let's go ahead and add it. Let's give this a number of the name. Doesn't matter how you spell it, vibration sensor number 10. Okay, so in this case, now we have, what port number are you on? So this one is number 4. Slave ID can be thought of as synonymous with Modbus ID or the device ID, and we just identified that it's ID 10. And if we, so now how many registers do we want to read? We can do one by one if we wanted to, but this does give us the ability to read multiple registers with just one rule. So we want to take advantage of that. So let's open up that data sheet. So if I go to the website, click, in this case, I'm using the QM30BT2. Search, it's going to bring you to this page. We have a great website. I encourage you all to use it. We have tons of awesome content on here. PLC data files. Okay, so the data sheet came right up. So if I click on that, now I can see all of the information I need. What we're interested in is holding registers. So holding registers, now I have a table of all the data that's available to me. I have 22 total registers, and notice that I have, Banner did this awesome thing, Modbus register alias address. So they're the same. They're the same data function, right? But these are in consecutive order. So this allows me to map everything in one read rule. So I'm going to start with 45201. So I'm going to read 22 registers, right? Because we said if you were to count from 45-01 to 45-22, that's going to be 22 registers. Let's just pull all of that information in there. So let's do 22. And now it's asking me registers starting at what registered address. So we said it was 45-01. Now the gotcha here is that you don't need to put that 4 ahead of it because we're already in the holding register. So, and it automatically populates here to 5222. So we know we did it right, or we counted right anyway. And now it's asking us, where do you want to put it on the local registers? So really, when we're making this register mapping, we're creating our own memory map in the processor board of that DXM-R90X1. So in this case, this value is actually arbitrary. I'm going to start at 1 and it's going to go up to 22. So if I drop down this window, I have additional settings here that I can look at. But if I go back to local registers and use, now I notice that everything's been created, all my registers have been created, but I don't have a name for any of them. So a quick way to modify all of these registers since they're in order is by using the modify multiple registers feature. So I'm going to start register 1, go to 22, and I'm going to click on, let's see, you need to make this set under name. Give it a name by 10 data underscore. And I need to make sure I have this check marked increment name starting at 1. And now I'm ready to modify here on the right side, click modify registers, and boom, everything got labeled. So you can go one by one and give it the exact description of that data point, but I'm not going to do that for this video. If I go back here to register mapping and I open this back up, notice that everything got populated here. So that's another quick check that you can do on your register mapping. So let's go ahead and do another one. Let's get that other vibration sensor. We know it's vibration sensor number 8 because I wrote to it earlier and I labeled it. So and I'm connected to port number 3. Oops. And again, slave ID, that's my device ID number, which in this case is 8. And it's the same vibration sensor type. So I know that there are 22 registers in there, starting at 5201. And notice now that I do need to start off on a different local register because I've already allocated 1 through 22. So I'll start at 23 just to keep everything consecutive. So I need to give everything a name here on my local register. So I'll go back here to local register tab and I start at modify multiple registers, starting register 23, ending register 44. See if I scroll all the way down and move my thing around. It ends at 44, right? So in this case, I'm going to give it a name, right? Vibe 8 data starting at 1. Okay, so I'll click modify registers. So all of that's been updated. So that is the gist of creating my read rules. It's very similar with RTU write. So if I have an output that I want to write to, same thing, I can give it a name, the port number I'm connected to. And now it's kind of inverted. So now it's asking which local registers do you want to be the ones to write to that Modbus ID. So we're telling it which local registers that, and this is going to be the arbitrary number that we create, right? And how many of them? And now we enter the device ID number, the Modbus ID number of the device, and then starting at which register. So this would be the Modbus address of that device, like the 5201 that we looked at earlier. In this case, it would be, in the data sheet of whatever device it was. If we're turning on a light, it'll have a Modbus address that tells us which address to write to. Okay, so now I'm ready to do a file save. File save. just gonna overwrite this one. Yes, okay. And now I can send it to my DXN. So I'm gonna go ahead and click send. And after it sends it, it was successful. Everything looks good. Now I want to read, make sure that I'm getting data from the vibration sensors. Want to make sure register source is set to local registers under register view and tools. Starting register 1, which is monitor, the max that you can monitor is 40. So I'm going to just do a quick read. Okay, so look, I've got data on here. Anyway, I think that wraps it up.